Air-Core and Ferrite coils explained. Freedom versus precision, the high-frequency guardians, Air-Core and Ferrite coils. In the vast orchestra of electronics, not every instrument can play the same tune. Some components are designed to handle the heavy bass of power transmission, while others are built to dance in the delicate treble of high-frequency signals. Among these specialized players, two types of coils stand out as masters of the high-frequency domain: the Air-Core coil and the Ferrite-Core coil. They are not the same, but each has earned its place in circuits where speed, precision, and clarity matter most. The Air-Core coil, pure freedom. In the world of electronics, every component carries a kind of personality. Some are heavy, grounded, and strong, while others are quick, light, and precise. Among coils, the Air-Core coil is a free spirit, unburdened by iron, ferrite, or any material that might weigh it down. It exists as pure winding and pure field. This freedom makes it one of the most reliable companions in high-frequency applications, where speed and clarity matter more than brute strength. How it functions in high frequency. Electricity is never still. In high-frequency circuits, currents swing back and forth at incredible speeds, like the rapid strum of a guitar string. Most magnetic materials struggle to keep up with this rhythm. They lag behind, wasting energy as heat and distorting the signal. The Air-Core coil avoids this trap. Because its core is nothing but air or a non-magnetic material like plastic, it has no sluggish material to slow it down. Its magnetic field forms and collapses freely, in perfect step with the current. This makes the Air-Core coil almost invisible in its work. It neither distorts nor delays. It simply allows high-frequency signals to pass with grace, shaping them with accuracy. That's why it's found in radios, antennas, and resonant circuits, places where purity of signal is everything. Strengths of the Air-Core coil. High-frequency mastery. It thrives where other coils stumble. Air introduces no magnetic loss, making it perfect for radio frequency, RF circuits. Stability. Its inductance stays consistent because air never saturates or changes under the influence of current. This makes performance predictable and reliable. Clarity of signal. Since no magnetic material interferes, the coil introduces minimal distortion. Engineers prize it in communication systems for this very reason. Limitations of the Air-Core coil. Size and bulk. Without a core to concentrate the magnetic field, more wire turns are needed to achieve the same effect. This makes Air-Core coils physically larger than their iron or ferrite counterparts. Lower energy storage. Air cannot hold a magnetic field the way magnetic materials can. The result is less ability to store energy, which limits their use in high-power applications, not for heavy lifting. While excellent for signals, Air-Core coils are weak when it comes to managing large amounts of power. They are sprinters, not weightlifters. During its working power, the Air-Core coil shines in the realm of high-frequency, low-power work. It is the unseen tuner in your radio, the whisperer in antenna systems, the subtle sculptor of signals. When steady performance and clean frequency handling are required, it is unmatched. But in the brute world of power supplies or motor drives, it steps aside. Their coils with iron or ferrite cores take over, stronger but slower. In this way, the Air-Core coil is like a pole in the world of machinery. Precise, refined, uninterested in raw strength, but unmatched when the task requires elegance and accuracy. Closing thought. The Air-Core coil is a reminder that sometimes less is more. By stripping away the core, it gains a purity of response that heavier coils can never match. It is freedom embodied. Not the strongest, but the clearest. Not the most powerful, but the most faithful at high speed. Whenever a circuit whispers at frequencies too fast for others to follow, the Air-Core coil is there, listening, resonating, and responding without distortion. It is quite simply the coil of pure freedom. The Ferrite-Core coil, the specialist. In the vast orchestra of electronic components, every instrument has its part to play. Some bring thunderous bass, some provide soft harmonies, and some step forward as precision artists, masters of their niche. The Ferrite-Core coil belongs to this last category. It is not a generalist like the Air-Core coil, but a specialist, perfectly designed for high-frequency performance where efficiency, compactness, and control matter most. The nature of ferrite. Ferrite is not metal in the usual sense. It is a ceramic-like material made from iron oxide blended with other metallic elements. Unlike heavy metal cores that invite large currents and wasteful heat, ferrite has a unique property. It resists electrical conduction but embraces magnetism. This duality, magnetically alive, electrically quiet, makes it the perfect foundation for coils operating at high frequencies. When wound with wire, a ferrite core does not simply sit as a passive block. It shapes the magnetic field. It concentrates and channels the invisible lines of magnetic force, preventing them from spreading wildly. This means a ferrite core coil can do more with less. Fewer turns of wire, smaller size, and still a strong inductive effect. Function at high frequencies. The ferrite core coil thrives in a realm where signals oscillate rapidly. Radio frequencies, switching power supplies, and digital communication systems. Here, ordinary cores made of iron or steel would falter, producing losses and distortions. Air cores, though clean, would require bulky windings to achieve the same effect. Ferrite strikes the balance. It steps in as a frequency sculptor, shaping how signals pass, how energy is transferred, and how interference is tamed. In high-frequency circuits, signal filtering. Ferrite coils act like guardians at the gate, blocking high-frequency noise while letting desired currents flow. Transformers. They enable compact, efficient transformers for radio transmitters, televisions, and modern switch-mode power supplies. Chokes. They suppress electromagnetic interference, protecting sensitive electronics from chaos. The ferrite coil is a silent negotiator between order and disorder in high-frequency realms. Strengths of the ferrite core coil. Efficiency and compact size. Unlike air cores that need sprawling coils, ferrite cores shrink a design while keeping inductance strong. Noise suppression. Their ability to choke unwanted frequencies makes them invaluable in modern electronics flooded with interference. Versatility. By adjusting the ferrite material, engineers can tune the coil's behavior for different applications, from broadband suppression to sharp, precise filtering. Heat resistance at moderate power. Though not invincible, ferrites handle heat better than many metallic cores when carefully designed for their purpose. Limitations of the ferrite core coil. Yet, every specialist has boundaries. The ferrite core coil's gifts come with conditions. Power handling limits. At very high currents, ferrite can saturate. This means a magnetic field overwhelms the material, causing the coil to lose its effectiveness. Fragility. Ferrite, being ceramic, is brittle and prone to cracking under stress. Unlike metals that bend, ferrite breaks. Narrow range of strength. Different ferrite mixes are crafted for specific frequency ranges. Use the wrong one and performance plummets. Heat sensitivity beyond limits. Excessive heat can erode its magnetic properties, leaving it less effective over time. The duration of working power. A ferrite core coil does not operate like a candle that burns away. It does not consume itself during use. Instead, its duration of working power depends on balance. The balance between frequency, current, and heat. When respected, kept within its design limits, a ferrite coil can serve faithfully for decades, regulating, filtering, and guiding energy without complaint. When abused, driven into saturation, or exposed to high temperatures, it may fracture, lose its magnetic character, or fail in silence. In practice, ferrite coils are remarkably durable in modern electronics. From a compact charger on your desk to the transmitters that send signals across continents, they quietly endure, their lifespan measured not in hours, but in years of stable performance. The identity of the specialist. If the Air-Core coil represents pure freedom, limitless, raw, unbound, the ferrite core coil represents mastery through specialization. It knows its field, it plays its part with precision, and it makes possible compact, high-frequency technologies that define our age. Without ferrite core coils, radios would be bulkier, computers noisier, and modern communication far less reliable. The specialist may not boast universal power, but in its chosen domain, it is indispensable. In summary, during working power, ferrite coils thrive in the middle ground. They can handle more power than Air-Core coils, yet still operate effectively at high frequencies. In the world of switch-mode power supplies, radio transmitters, and noise filters, ferrite core coils are indispensable. Air versus ferrite, the great balance. The Air-Core coil is like a free runner, fast, light, unburdened, but unable to carry heavy loads. The Ferrite-Core coil is more like a martial artist, compact, strong, disciplined, and able to handle heavier tasks, though not without limits. Both types are crucial to the world of high-frequency electronics. One preserves purity, the other balances power and precision. Together, they keep our signals sharp, our communications clear, and our devices efficient. Closing thought. At high frequencies, not every material can keep pace with the rapid heartbeat of alternating current. Air offers freedom. Ferrite offers focus. Knowing when to use each coil is the mark of a wise designer, one who understands that in the symphony of electronics, sometimes you need the airy notes of purity, and sometimes you need the grounded strength of discipline.